So when it's new, like I said, 6,000 volts. Now, as the years go by, though, all the starts and stops and all the stuff that Ed was talking to you guys about, the heat, contamination, vibration, all that stuff put together is why that it starts degrading over time. And eventually, it can only withstand 5,000, 4,000, 3,000, 2,000, and you get down to bus voltage, and you start having a problem. That's when the thing's going to blow up on you. So we're testing, first of all, at the bus voltage. You're at 500 volts, and that's how good we step it up clear to the 2,000 on your 480 volt motor. So this is your window of opportunity in here of us being able to find a problem before it blows up on you. So it eventually gets down to bus voltage, and there's a problem that's going to fail in real life. Thermal contributors. So load, increased current makes the motor run hotter. Like Ed was telling you, heat is the enemy. Ambient conditions. So if it's in a really hot room, it's also going to make it run hotter. Altitude affects this. Starts and stops are huge. Like you were saying, you can just start it and leave it running. It's your best bet. I know it's not very practical, but if you can help it, try not to start it over and over again. You know, especially like I see people do it and they're troubleshooting. I had a guy actually. Yeah, right. Depending on the size, you know, big motors. Some of the big motors you can only start them once per hour, or if you do 2 in an hour, then you have to wait 24 hours to start them again. I'm talking about, you know, like 2,000 horsepower motors. But, yeah, we deal with a lot of that too. And I had a guy call me the other day and he said, I think I need you to come out here. We got a problem. I hit the start button and I heard a loud boom, and the motor didn't run. I said, what'd you do? He goes, I called my boss. And I told him about it. And I said, well, what happened then? He goes, well, he didn't believe me, so we hit the start button again. I said, well, what happened that time? He said, well, we seen smoke come out of the motor. I go, yeah, I think I better come out there. And I said, was that it? He goes, no, well, his boss didn't believe him either. So, so I said, well, what'd you do? He goes, we hit the start button the third time. I said, what happened then? He goes, the telephone pole caught on fire. I said, don't hit the start button again. I'll be right down.
Oh, really?
Yeah. The county one.
You did that.
So thermal insulation from contamination. So if your motor gets full of dust and other crud, like you were showing you pictures of, it's going to run much hotter, and this is not going to live as long as it can't cool itself off. Power quality is a big one. So this is what we test for with the online test equipment that you were talking about, asking me about. Power quality, harmonic voltage factor, under and over voltage imbalance, all that kind of stuff generates a lot of heat. That's one reason it's a big deal. And it's really hard to see most of that with just your fluke meter. Plus, when you're using your fluke meter, you're looking at one phase at a time. So we can look at all three at once, watch it real time. It really helps with troubleshooting. So keep that in mind. I think this is going to be the video that we already showed you guys from Ed's video. Talking about the thermal aging. Oh yeah, so I think Ed touched on this also, but for every 10 degrees Celsius rise in temperature, the insulation degrades, the insulation life gets cut in half. That's what it's all about. Yeah, that's how they preach that in a lot of different schools that you go to, so it's a big deal. Sounds kind of crazy, but it's true. Contamination, chemical deposits, like I was saying, anything that builds up inside the motor, and that whining, also like that GE movie that we showed you, the D.E. Crawford one on the startup, and the whining pulsing. All that contamination, especially if it's abrasive, it's just rubbing that insulation that I told you on the wires, rubbing it off, and that's the other reason that we like to do the testing above the 500 volt range, because we can pick up those weak spots in those individual wires. You know, we won't know exactly what, but we'll just know that it's there and kind of give you a heads up to the problem developing. And a lot of it is because those wires are moving. Start like that. Mechanical, that's mechanical movement that we're just talking about just now. And thermal growth of materials, when it gets hot, things expand. that also causes those wires to rub on each other. Over voltage spikes, especially from VFDs, that's a huge contributor. And lightning. Oh, so here's that video again. There's no sound to this one, I guess. But you can see how it's pulsing, and those tie strings are all stretching. You can even see it moving in the slots. So what's actually happening inside during turn short? Go to that video, right? Yeah, okay, cool. That's the video we saw earlier. So benefits of doing the Megome dielectric absorption or PI test. Like I said, the PI is on the bigger motors, but just the benefits of the Megome testing is so you can confirm the integrity of your ground insulation system. So your Megger's you're just mainly testing if the motor is grounded or not. I have a lot of people I run into that think that there's a lot more to a Megger than that, but really that's what you're doing is seeing if the motor is grounded or not. Detecting the presence of moisture, so that's a huge one. Also, like you were asking about if the motor sits for a while, that's one of the problems with it being cold, or if it's in any kind of a humid or outside location, it tends to draw moisture, and that will definitely bring your Megome readings down. And it's all stuff that you want to know before you hit the start button, or a lot of people want to know. It's going to blow up when you're not. Regular testing over time establishes the history. So, like I said, we can record all that data inside the software and trend from test period to test period, so that you can take some preventative action at a certain point when it drops too low. Makes you kind of an informed maintenance group, if you will. Surge testing, test insulation integrity of the coil turns to one another. So actually turn to turn, face to face type problems. And that's, once again, usually is when the wires start, the insulation when the wires starts getting thin from all that movement that you saw. Or sometimes things can get in the motor and nick those or damage it. 80% of stator electrical failures start as copper to copper faults. And that's that video we showed you earlier with the smoke coming out. They're just the induced to turn short, and it took like a minute before smoke started coming out. But the thing is, if we could find that at a higher voltage than 480 volts, so we can find it at 1,000, 1,200, 1,500 volts, that's what we want to do, because to let you know that, hey, eventually it's going to happen at 480 and your motor's going to fail in minutes. But if we find it up in those higher ranges, it gives a longer time. Think about changing that motor out. So we raise the voltage potential between the turns, and we're looking at we're chopping up a DC signal really fast, sending it into the winding, and we're reading that response coming back into the tester, and by looking at that waveform, we can tell if there's a problem or not. Just any more questions?
Are you test rotor bars or anything like that?
Yeah, so the online test equipment that we were talking about, test rotor bars, we need to have at least 30% load on the motor, but and what I do is I take the nameplate information off the motor, I enter it into the test before we start, and that's how the test equipment knows what we're looking at. And based on that, we know what the frequency of interest of that particular rotor bar is. So we're looking for a certain spike at that frequency of interest, and if the amplitude of it is too high, we know we could possibly have a rotor issue. So yeah. That's another nice thing about it.
Yeah, there aren't any really good, easy ways to do it though in the field, other than this or the other. The Baker's competitors, PDMA, and they also have a test. Otherwise, it's a shop test.
Best
thing.
thing.
Magnetize the rotor in the shop. Yeah.
That's this will give us a good idea. Yeah, looks like there might be a problem. I want to bring it in.
It isn't a common problem, though. I mean, certainly something the shop doesn't see.
It's
a
typically
couple times a year, probably.
Typically the larger, real severe duty effect stuff. Like, what else you guys got?
Somebody wants to know what we're looking for on a Megger to determine good readings.
Yeah, so it's based on the voltage of the motor. You got to deal with a 480 volt motor. And there's a rule of thumb, and there's the industry standards. But basically, I think for a 48 volt motor, the cutoff is 2 megohms, which is the very lowest. Typically, you'll see it way higher than that, but anything below that, you wouldn't want to try running it. Although, having said that, I've seen them run down below 1 many times, but that's an unsafe level.
So I have several compressors, screw compressors that are like 0.025.
Yeah, so
and they're
that's
still running. I'm like,
gambling. Right? You're taking a chance.
Too.
You're taking a chance.
Yeah, and that's where when we're looking at that with a customer, that's that point where it's a recondition. It's probably dirty, oil contaminated, whatever. So that could be brought to life with a recondition in the shop, or it'll just continue to degrade and then it'll be a rewind or replacement. So the difference is significant when you start talking repair costs. But a lot of customers don't care.
You will get lucky
They'll deal with it when
quite a
it
few
happens.
times where they will, but I do promise eventually it'll hit it and it'll go boom. It'll only put up with it for so long.
Yeah, I told them. It's been doing that for about 5 years. So.
Yeah,
Whatever.
keep it running.
Now.
Keep it running.
There you go. And then they'll bring in a different.
So back to that question though, I would consider on a 480 volt motor.
It's on.
My test equipment gives me an alarm at 10 megohms. So that's at that point is when I would be telling my customers, hey, you should start thinking about doing something. A normal reading on 480 volt motors would be above 100. All the time they're in the thousands. So,
Make it
500 volt. What else?
Can a VFD induce a harmonic that sounds like a failed bearing? And what can be done to reduce the harmonic frequencies on motors connected to VFDs?
These are one huge thing. They'll help cool blues, help harmonics, and high frequency stuff. And they do at these, especially the NALAs, I think, are for the real high frequency stuff. But I've heard VFDs make all kinds of crazy noises before. If it sounds like a bearing or not, that's possible, sure.
So let me ask you this, when you guys are setting up VFDs, well, do you set up and program VFDs for your customers? You enter the parameters and commission the drives? Okay. Are they concerned about that switching frequency, that where your carrier frequency is?
A lot of them are
audible?
that line.
Yeah.
Sometimes.
Most of the time, though, our equipment is not located in an area where it is really noisy.
Yeah.
We have to worry about the noise.
So if
if
they're-
they run the switching frequency down
Yeah.
low, and it creates more noise, but
if they can't hear it,
it's easier
right.
on, it's easier on my
cooler.
motor.
Yeah,
Just
it's
right
way
off
better
the-
on the
yeah.
equipment.
Yeah.
So if they're not, sensitive to the sound of a high carrier frequency, they can turn it down lower. That's ideal, if they can deal with that. If they can't, you're putting harmonics. That's the nature of the high frequency switching device. It overshoots, it's the harmonics it produces. So taming the output of that with a cold blue is a good first step. If you can't lower the carrier frequency. And I understand it, especially in the HVAC world, amplifies through all ductwork.
It's a nice cost-effective step. There's other filters that are out there that are way more expensive. I would start with something like this. See what that does
Cool
for you.
Blue actually knocks out some of that sound.
I don't know about the sound, but the actual high frequency
just the-
noise itself. Yeah, I don't think it'll to your ear. I don't think you're going to hear that.
But you're still going to hear that. That's carrier. You're hearing the carrier
Yeah,
frequency.
you can definitely see it on an O-scope though. The Cool Blue does. We'll show you that.
You're reducing the fluting of bearings basically with the.
Yeah, we're trying to get the common mode current down to a point where it's not, the amplitude of it's not high enough to discharge into your bearing. Yeah.
Cool.
Yeah. Roughly, yeah.
I have 40 motors connected to the same drive. I think that's a mistake.
I've heard of 4 before. 4, yeah. That must be a big drive.
Oh, 1 out of 40. Sorry, Brandon. 1 out of 40 motors connected to the same drive have this problem. I'm not really sure what he's asking.
Yeah, I see that a lot. You'll have 40 drives. Well, maybe that's what
Everything runs fine, and then you get
Absolutely.
you get the one that
So
acts up.
lately in my life, I've been getting that question a lot. I was just at a place called Solar World, and the engineer there is driving him nuts. Why? He has two identical pumps and motors side by side. One of them bearing fluting like crazy, and the other one doesn't have a problem with the same drive, same cable length, everything. And I don't know that there's a really good answer for that. A definitive answer as to why, but
Probably
it's,
a drive.
but it's definitely not just you guys that see that. It's happening all over the place. I've seen it a lot.
Whose drives are they? What brand?
These last ones were ABB.
Probably ABB.
What do you see most? Danfoss or ABB?
Oh, that's a variety.
ABB.
Yes, there is. By far.
ABB.
He's cheap.
That's a right call.
Yasawa.
So one thing I want to mention, Dave and I recently got certified with ABB as DSPs, so we're drive service providers for their whole product line. So we can do commissioning, startup, troubleshooting, component replacement on ABB drives. We're factory authorized, paid by the factory to do that work on warranty stuff. So in situations like that, we can, you know, we can take a look at something if it's a real problem.
Yeah, can you talk about the Cool Blue and kind of how? Is that something that you were?
I don't have a presentation at all, but I guess we can just kind of have a little bit of a roundtable. You've seen the most of it, so.
Most people have seen them. How many have installed Cool Blue? I know there's a few people here that have. Yeah, so.
So
How do you 20%? Yeah, how do you install them?
yeah, so I can talk about that too. I mean, that's what's neat about them. They're pretty cost effective, and the installation is easy. So the cores themselves are the Cool Blue cores. They can come round or this oval type shape, and all you have to do is pull all three phases loose from the VFD of the starter, and slip these over all three phases. And then if you want to use the NALAs on small motors, the 10 horsepower, and below they always use these, but on bigger motors for when you want higher reliability, they also use these NALAs, and they go on the single phases. So then you just bolt it back up and you're done essentially. Maybe some tie straps, make it look nice.
They say you want them as close to the drive as possible.
Yeah, you do. You do want them as close to the drive as possible. So they usually go in the drive cabinet or the motor starter bucket or real close to that, like a raceway. And what's inside of these is real similar.
That one's open. The middle one without the
So you've
tape
seen
on it.
inside of it?
Oh, I for a second did.
It's kind of hard to get a show together, right?
No,
On the big ones.
that one's been apart probably 2 dozen times. It's losing material.
Yeah.
But
So it's laminations, basically similar to motor laminations, but super thin. I've measured them on the biggest size folder they have. They're 1/1000th thick. So there's think how many of them are in there, and it's a very very special kind of metal that they manufacture over in Europe. I can't remember what the actual name of it is. You imagine it's a company. Anyway, they stack them all in there, and it's filtering out, and it's acting as a common mode choke, and it's taking the common mode current, and it's reducing it to a point where it's not going to hopefully not be able to discharge the bearings anymore. And it's also slowing the leading edge rise time of the waveform down. And this is stuff that we can do before and after test with the oscilloscope and kind of show you. And to size these, it's based on horsepower and lead length. And there's really easy application guides to follow to tell you which ones you use and how many of them.
Spencer put together, you guys probably saw him like 2 months ago. I sent out an email about the kits, and Spencer put them together for us. That it's about $250 for a 20 horse to do those. And if you want to grab those, have you guys all seen those things? I have Cool Blues. Yeah, let me see.
Now, those bigger oval ones, you're sliding all three
Yep.
lines through the one.
Yeah.
And then, so you're saying, there's a chart that tells you how many to use for what size?
Yeah, so,
motor,
yeah, basically you just look up, okay, I got 50 horsepower, and the lead length is 150 feet or less. I need 4 of them, I need this part number. Or you can just call, you can just get a hold of us and say, I need a part 50 horse, and this is my lead length.
And then the little guys, you're doing individual pays.
Yep.
Same thing, so
Same
you'll
kind of chart.
so many per phase.
Yep, same kind of chart for that.
Out of curiosity, are you guys wrapping around the cool blue one time thing going through?
Oh, well, I know what you're talking about, but it's really hard to do on any kind of a sizable cable. But if you can do that, it's even more effective.
It is.
Yeah.
And one question, is Travis, I think, is Travis here? Yes, Travis is on the text. Okay, yeah, so Travis had asked via email if we could, for 1/4 to 10 horsepower, you have to double loop it through the cores. And Travis had asked if we can add another core or do something so you don't have to try to make that double loop, and the jury's still out, so they're running that one back through.
So instead of looping your wire twice, you just add another ring.
Yeah, we're trying to find a way that we don't have to loop it twice.
A lot of times those drives, I mean.
The length is already.
Yes. Just how many you need to equal the same amount is the question.
That's what the
Just about connect the.
What's that?
They said that that's the reason why we have to loop it was to keep temperature rise off the.
No, you know that not really. The temperature they do get rid of some of that noise through heat, but it's a negligible amount. Like if you watch it with an IR camera, it just gets a little bit hotter. It's nothing significant that you need to worry about.
So why do we have to double it?
So that's just like making when you make a coil around it. It's just more surface area of the wire around the core.
Oh,
I think it's
I think it's almost like the current sensor
Yes.
that we do.
Yeah, it's like a CT. Yeah. Right. Yep.
Yeah, so I actually need to follow up on that. It's been a couple of weeks, I think, since I sent them the email to find out if we can do that. Yeah.
So one other thing I'll tell you is with the online testing stuff, we can also do transient analysis where we can see there's a special feature on it where we can see like contacts closing during a startup. It's doing like a lot of samples per second, so it's a really good resolution. And so I can record like a soft starting or a VFD starting and see every step along the way and make sure that it's really operating the way you program it to operate. You have weird problems like that or bad contacts in a starter.
Your test will differentiate structural harmonic or bearing. That's what it's. So can you tell me essentially what your bearings are fine that your harmonics are
I can, especially if I know the bearing size and the bearing manufacturer. That's the best case scenario. If I at least know the bearing size, for sure we can look at that. But the electrical harmonics are going to be a totally separate test than bearings. But yeah. So I get called out a lot for the mechanical versus electrical argument that places have. You know, it's the motor, no, it's the pump, that kind of thing, and it really helps solve a lot of that too. Especially if you combine it with one of the other technologies like the vibration analysis. It really helps. Right.
You guys got any more questions on Cool Blue? Or Certi?
I'm sure Doug will.
Throw him under the bus, Sam. How do they pull the metal out of it?
You'll be about 3 hours of my life.
You know, it'd be nice to have Dennis down with his little transformer light bulb.
Yeah, so maybe
Just how cool.
if we can set up a day and time, then I can show you the motor testing demonstration. At the same time, we can do the full blue, possibly. Yeah. How often do you guys get together like this?
Too often.
Too often? It really really be ideal, you know, we'll have to.
It's the last one for the year in Seattle.
I could do it on
It's
a
not
motor.
me.
I can do it on just a regular motor that you have sitting over there. But also be neat if I could show you the online, so we go someplace that has a motor running.
The only way to get people.
Did you mention about a dielectric absorption ratio and polarization index testing?
Yes.
The
PI. So the PI.
Oh, that's the PI.
Yeah, and on motors that are under 100 horsepower, we do the dielectric absorption test. We call it a DA test. And it's just a shorter version. So if you had this last for 10 minutes, the smaller motors, we do the DA test, the dielectric absorption, that lasts for 3 minutes. So, and that's just another way to look at the general health of the slot liner insulators.
And that's putting power to a motor and then sit there?
It's just like, you can actually do it with your Meg, or if you can hold your finger on the button long enough. I mean, it's putting the 500 volts on there and holding it for 10 minutes long.
10 minutes.
Yes, but then you need to know the ratio. You're dividing what you get 10 minutes by 1 minute, and there's a scale that tells you where you're at, how it looks.
I hold the button a long time.
Oh, you do?
So you don't have to sit it up.
Oh, yeah, the big one, are really too. Really careful.
You can dump it out of there.
Yeah, they will, they go to
David, is there any of the testing stuff that you've done with Cool Blue?
I have one account.
Yeah, so I have
Dave's done a fair amount of Cool Blue installation and stuff. Just wanted to kind of talk about some of the ones that he's done and maybe why they did them, and the testing and some of the results that we've had.
Did somebody want to know what your turnaround is to Seattle for getting a motor here? I think probably both scenarios. If we had one we wanted to send to you, should be rebuilt or retested or something of that nature.
Yeah.
What's your average turnaround in 2.5 days?
Yeah, we're back and forth almost every week. If it wasn't something that was a rush, and it was, we'd be up here the same day.
Do you guys like
Emergency.
So yeah, we're a 24-hour service. That's what I was saying. And I dispatch all the time from my house. And I just to be as quick as nighttime. I just basically get in the vehicle and head away. So
I mean,
2
I know
hours.
it is like, so if we call your main number, this 8700 number, 2 o'clock in the morning, and hey, we got a 75 horsepower that just gone, we need one. Like a hospital or something, get up and run by.
Yeah, it's pretty common.
Hours, you know.
That's what my life looks like. It's pretty common.
Right.
You call that number, we have an answering service, and they'll get a hold of one of us. Or you can call my cell phone number, is the best way on the other card, and it goes right to me, and it always wakes me up.
And do you guys have a stop on?
Yeah, we start from 1 to, we've always got through 500 horsepower, 4 and 6 volt. We don't stock a lot of 3600 RPM, but we do have some. And then the Baldor warehouse is an hour south. I don't know, you probably get into the Baldor warehouse and just don't know it sometimes in the middle of the night thing, but it's coming out of Portland. But yeah, we have GE and we're also a Tico Westinghouse distributor. We've got both Tico and GE up through about 500 horsepower. Yeah, the 8700 line, we have, somebody always answers it, which is something I haven't wanted to do away with. So there's not a recording and a list of phone numbers or anything, so there will actually be somebody that answers the phone, and then they start calling the phone tree, and I'm still the first one that they try. So I field those calls, and then these guys are down the line if I sleep through it or I'm out in the woods. So we've got trucks during the day up here, quite a lot going back and forth. But middle of the night, it's 2 hours to here.
And we do a lot of, if you need help, bearing changes, stuff like that. We do a lot of on-site bearing changes. I can bring motor mechanics stuff. Gear bearing changes. We can help out with installation. We do it all the time. I saw you in laser electrical back there. That's something I do all the time. So if you need help with that kind of stuff, no problem. I can't really help you with the SKM one very much. I use it, but use rotor line, off the line.
SKS just an app.
Yeah.
Oh, is it?
It's cool. Yeah, good. Real quick, I'll tell you what, one case study for Cool Blues that I just did, was at the Solar World factory where they make solar panels, and we had a 60 horsepower horizontal pump motor, and they know already that they have flutings. They already have taken the bearing out and showed me the fluting. And so we went just recently and put the OSCO on before we did anything, just recorded what the common mode current amplitude levels were, and then we shut it down, installed the cores. It only took maybe 15 minutes, and started back up and put the OSCO back on it, and we saw about a 35% reduction in the common mode current. That's pretty significant. Now, hopefully that's enough. What we tell people is if you want to be sure, you can use a shaft grounding device and the Cool Blue cores.
So you guys haven't doubled it and then seen what those results are then yet? You're going to try that?
Yeah, I have in the shop doing experiments with our electrical engineer. We've done wraps around it.
I mean, two sets, like you were saying, multiple cores.
Oh, you mean just keep adding cores, see how much each core helps?
Curious about
I don't know. I know that it gets better. Like I just put 20 of them on a wind turbine because they didn't know they didn't know how much to put on it, and so they said we're gonna put 20 of them on there, and we didn't.
Well, didn't Hans wasn't that? Didn't you guys get some measurements or something, and they did decide?
We did measurements, but they wanted to just be sure, so we put 20 on that one, and if that works, we're gonna start taking them off and see at what point. This is for a different problem. It's causing gassing in the oil of a transformer, but still from the same root cause, the high frequency noise.
Is it linear or not? Not yet. You don't know.
Yeah. It is. I just don't know. I just don't know.
35%?
Yeah, I just don't know how much. We should probably do a little bit more testing there to see how much each one adds. And it might be different from application to application too, how the severity of the problem.
Yeah, we'll have, see if Dennis can join us, our double E next time, and he's really the one that vetted the Cool Blue for us. But what we do know is that different size bearings have a different tolerance to current, right? So the larger the bearing, the more it will tolerate before you start having issues. And so, so we don't need to necessarily get that down to 0%, right? When we're seeing that current. So what we're trying to do though is just lower it below the threshold at which we start to have problems. And so that's the goal. And we can. Did I share any case studies with you at all, Seth?
Yeah,
so you got a few. Dave just found another one on LinkedIn or something that came through. I'll forward that to you as well. But what we know is that we can calculate what the ampacity of a bearing is, and then kind of back into whether or not Cool Blue has done enough. But that's all through measurement with the Rogowski coil. But what we have seen pretty commonly is like a 30 to 60% reduction in that common mode current, which is in most cases plenty.
And that started with brand new, so you don't have the panel yet to install. You're trying to extend life of it. Have you done anything or seen any, have you had any experience yet where you've already had the fluting, you stuck it on there, and
I've got I got one that's been out there for almost a year. Yeah, it's almost 2 years. But we haven't pulled that motor out of service, taken a bearing out of a rather large motor. But it hasn't been the same token, it hasn't failed the bearing either. So yeah, it is fairly new. I'm anxious to see those results.
Nippon, it's now Nippon Paper, it was Weyerhaeuser down in Longview. They just put Cool Blue on they've got like 23 horsepower motors on one of their machines, and they were lasting in the months before they were wiping bearings. All of them were having the same problem, and so we just got a note from him the other day. It was about 40% reduction in that common mode current. but it's, I think that was last week that he just did that follow-up testing, so we don't know yet.
He
what
uses
the-
an
what the
AD
long-term
pin, like
is
an
gonna be.
electrical discharge, measures the ED.
So,
Hopefully that.
now the guys that, we took a long time, just kind of give you a little background on us and Cool Blue. We almost got fired from the conversation to become a distributor because we took a lot of time just talking to other folks. And Dennis, our double E, spent a lot of time with customers and other folks throughout the country just trying to vet it as a technology because it is kind of, it seems a little snake oily, right?
Yeah, we are skeptical.
And we had to put enough in inventory that I didn't want to do something that was not legitimate. But talking with other folks that are selling a lot of it back in the Midwest and East Coast particularly, they're having really, really good outcomes. I talked about that ghosting in that factory earlier. That was a Mars candy bar factory. All the cool places are back east. I don't have any candy bar factories. But they were having just equipment shut down, and it was solved by adding Cool Blue to the system. Just that noise, once it's on the grid, it's just wreaking havoc all over the place. There's been a lot of cases where guys are talking about it working. We just haven't been selling them long enough to have them track it.
There's some motor manufacturers that are endorsing it, right?
Yeah, Tico Westinghouse says if you've got fluting, you can do a shaft grounding device and insulated bearings, or install Cool Blue. Danfoss and ABB and I think Yaskawa are all including it as an option on new VFDs. So you can buy it with the VFD. So we're starting to see it from the big manufacturers, and so I think it's going to become easier to sell as people start hearing about it. And then Aegis is the big shaft grounding brush guy. No, they don't.
I mean, there's
They
not even
don't.
worth the effort to put them on.
That's one thing we know for sure is that grease and oil on a grinding brush or an Aegis grain, once it gets a little bit on there and starts to get saturated, that just, the effect of it just tailspins. It just drops off. Yeah, just
And so, but they're coming after Cool Blue really hard.
They're not like these.
And so it's if nothing else, Cool Blue is getting talked about a lot, and so I think it's going to be easier for you guys to talk about with your customers and sell because it's getting referenced a lot out there in plant engineering mags and the stuff that are customers.
Just not sure why they don't put it in the body of the drive. That's why it's got to be external.
Why is it not incorporated?
They're starting to. That's
I think that some of the motor manufacturers would just put a brush on the back end of the motor. When it comes straight out, if they know that we're putting, the drives are so commonplace.
Yeah.
Then why aren't they manufacturing that in there?
I think the technology hasn't been around for that long, so ABB has their own version of it, I think, right?
Yeah. A version of this has been around for at least 30 years. It's a toroid, basically. That's what this is, a corn coil toroid. And the only difference between this is the composition of that coil is proprietary to them. It's a special composition. Other than that, very similar devices installed, or used to be installed on almost all drives. They just got away from it because of the cost. Standard little drives are just super competitive. I mean, dollars matter if you're a manufacturer on that. So they shave pennies out of those drives wherever they can. They're available as an adder from ABB, I know, probably AB as well. And I think they might even include a similar product on standard on some of the larger drives, but it's not Cool Blue. It's not, unless they're buying it from Cool Blue, it's not Cool Blue. You know what I mean?
No,
Are they buying these now?
there are OEM accounts with those guys. So it is a Cool Blue option. So, and then having Tico Westinghouse, certainly that memo is helpful. Train on some of their chillers. Actually, do you have a card by chance? I'll give you one of mine and you can email. There's a train document where they're using it on some of their chillers. So that exists out there from Train, which is really helpful as well. So I'll share that with you, and you'll have it to reference if you need it. So it is definitely getting some traction. It's just we're the first ones that are actively selling it out here in this market. So it just hasn't been talked about a lot.
You guys all have my email and my phone number now, so anytime you need to just call me or email me, and I'll get back to you really quick.
Yeah, that's awesome.
Yeah, no problem. Questions?
I got that thing that you were talking about from
All right,
training.
thanks for coming, guys.
Okay.
Yeah, thank you guys. Nice meeting you all.
Thank you, guys. I don't think you can hear me, but thank you.
Thanks,
Thanks, Seth. You can hear me. Seth, can you hear me? Seth, can you hear me?
Anyway.
We should hold about that.
It's not new technology. You see them absolutely everywhere.
Yeah.
Still trying. Nothing?
Can I see that real quick before you put it away?
Hello, Seth.
Geez, I didn't even mention all the nice hockey paint on there.
You don't get to see them cut apart like this too often.
Yeah.
No, it's cool, isn't it? Yeah, I think trade school was the last time they did anything like that. A long time ago.
Evidently, nobody else can, Brandon.
I can hear you, Eric.
Now you can hear me?
This is Travis, though.
Okay, Travis, yeah, I was going to say, I've been talking, and I tried to ask a bunch of questions. Nobody can hear anything there. I guess he's got it muted or something.
I just text him to make sure that he...
How do I know if I'm muted?
Are you muted? Whoever just said that.
Who said that?
Jimmy?
Yeah,
You're unmuted, Jimmy.
You're unmuted now.
If my mic is blue, does that mean muted or not muted?
Not muted. There'll be a line through it if it's muted.
We've been listening to you the whole time.
Oh, this is going to be awkward when I come to work tomorrow.
Seth actually had it locked out.
Yeah, mine always has a line through it.
Bill?
If I click on it, it's always got a line, but if I click on it, it'll turn blue or go clear.
Yeah, weird. I'm not, of course, I'm on a desktop. You're on your pad. So
yeah. Hey, I like this. This is pretty cool.
Yeah, it's really good. We need to come up with a better mic location.
Yeah, as soon as people in the background started chatting, I couldn't hear anything.
Me either. It says he's got noise there.
What color does your mic have to be?
See, it's if it's blue, you're mic or you're muted.
I gave up on my iPad and went to my laptop. It was.
Oh, some of us.
Yeah,
don't
that
have
was me,
Travis.
So if you're blue, you're muted.
Yeah.
Okay, that makes sense now because I've been blue the whole time.
Interesting. I'm blue without a line in mine, and I'm not. I'm unmuted.
Yeah, well, we have a line. No, whether we're blue, there's a line, or whether it's clear, there's a line.
Yeah.
Yeah.
Good learning experience there.
Yeah.
Figure this thing out sooner or later. It's awesome. Just got to get some of the bugs worked out.
Yep.
Yeah, totally.
Yeah, this is great. It'd be nice if we can come up with a new mic and speaker location. Put the speaker up onto the overhead and then have the mic up in the front of the room where the presenters are, so not where all the chatter is going on in the background.
Either that or a portable mic that's on the guy that's talking.
Yeah.
Yeah.